Okay, hello everyone, good morning. Audible? Morning to all, am I audible? Yes, hello. Okay. Good morning to all. Okay, so in the last lecture we had started the assignment, unit number 6, planar and non-planar graph. And we had discussed the definition of planar graph, which graph we can say as a planar graph. Okay. So the definition is that it can be drawn on a plane such that no two any edge are intersect at non-vertex point. So that type of graph is called the planar graph. Okay. If directly one of the graph is given that without crossover, then there is no any need to modification. Okay. उसमें कोई modify करने की जरूरत नहीं है. Here it is a one of the example is that planar. Okay, with 5 vertex, and you can say that no any edge are intersect. So it is a non-planar directly. You can say. Okay. But some graph we have, okay, and in that graph we can apply the embedding procedure that to make the graph as a planar. Okay. So at last we get conclusion it will be the planar or not. Okay. It can be drawn on a plane so that no two any edge are intersect. Okay. Right now the situation is a non-planar, but we can easily embed the situation as a planar form. Clear? We can easily embed the situation as a planar form with same vertex, same edges. Clear? K4 graph. So at last, the conclusion of K4 will be planar form. Okay, and that is another one. In that embedding is not possible. So the graph is called the non-planar. Okay, in the last one, it is non-planar because उसमें possible नहीं है. ठीक है? So the definitions we had discussed in the last lecture, there is embedding procedure to convert non-planar to the planar. And then after we discussed the applications, where it is required and what is importance of planar graph in real life as well as in engineering field. Okay. So it gives the idea to develop a network of utilities such as a electricity network, gas pipeline, water pipeline. And after it is also used in a circuit board, okay, of any of the electric chip. Then after it is also used in the subway system, we can use the concept of planar graph to develop such networks such a way that no any two network can be less. Clear? And after that, we discussed this topic also. Two special graph. These graphs are known as a Kurosawa's 2 graph. First is a K5 and second is a K33. Okay. First Kurosawa's graph is a K5 and second Kurosawa's graph is a K33. Okay. And we already checked that why it is considered K5 directly. Okay. Why it is not for K4. Clear? Why it is not K3 and so on. Because up to the K4 we can easily embed that graph to the plane. Okay. Up to the K4 it is possible that, but after the K5, okay, K5 and after the K5, is it not possible to make this graph as a planar? Okay. So first we consider K5 graph, which is a non-planar, and in the complete bipartite graph we consider K33 graph up to the K33. Okay. जितने भी graph है, you can easily embed as a planar graph. But for a K33 and after K33, it is not possible to make the planar graph. Okay. So that is consider the minimum possibility of vertex and edges. And then after we discuss this theorem in the last lecture, we prove that complete graph with 5 vertex is a non-planar. हो गया था? Complete graph with 5 vertex is a non-planar graph. Okay. So you have to apply the embedding procedure to the K5. Okay. What is the actual shape of the K5? Let me consider this one. Okay. That is the shape of K5. And now apply the procedure to embed it. Clear? So how we can apply embedding? Consider there are crossover to the inside the graph. Okay, so remove such crossover such a way that can we draw this graph without crossover or not. ठीक है, वही सिर्फ आपको explain करना है. So that consider step by step here. Consider 5 vertex is a V1 to V5, and then after plot it to the plane, and then after connect it, make one chain, okay, one circuit, and that look like now pentagon, okay. And then after there is a two region in the pentagon. One is inside region and second is outside region. Okay, that is the step one explanation. And then after in step 2, we'll connect some more edges. Clear, all the 5 edges of the boundary are defined. Okay, we connected all the 5 vertices of the boundary. Now 5 edges to the inside is remaining. So let's pick up any one of the edge. Clear? That is considered V1 to V3. So for V1 and V3 you have the two choice. One is inside and second is outside. ठीक है, आपके पास दो चॉइस है, एक इनसाइड की है, दूसरी आउटसाइड की है. ठीक है, यू कैन कंसीडर एनी चॉइस टू कनेक्ट V1 and V3. ठीक है, that we explain in the second step. We connect now V1 and V3 by means of an edge. It may be drawn inside or outside the pentagon without intersecting the edge. Clear? Suppose that we choose to draw the line V1 to V3 inside the pentagon. Okay, that we consider in this graph, and we can also choose the outside the pentagon. Clear? And we'll get the same conclusion at the last. Clear? That is second step. Now third step, we will consider inside edge from V1 to V3. Clear? Now let's connect V1, V2 to V4 and V2 to V5. Clear? So here we cannot use the inside route, okay, inside region, because if we use the inside region to connect V2 and V4, it will be crossed with the V1 to V3 edge. Clear? So we have only one possibility to connect the V2 to V4 and V2 to V5. That is a outside possibility. Okay, so here I have explained here. You have to draw the edge between V2 to V4, V2 to V5. Since neither of these edge can be drawn to the inside of the pentagon because one of the edge is already drawn. If you draw it again, it will be crossed with this edge. So consider only the outside regions to connect it. Okay, so that we consider in this figure in this graph. Okay, and then after in next step, till 2 edges is remaining to connect. Okay, how many edges we have considered? 8 edges. Clear? 5 are the boundary, 2 is the outside of the boundary, and 1 is the inside. Okay? So still 2 edges remaining. So let's consider this 2 connection. One of connection is V1 to V4, and second is a V3 to V5. Okay? So here from V3 to V5, we can use only the inside the pentagon. Okay, inside the graph. If we connect it outside the graph, it will be crossed with the outside edge. Okay? So there is one choice to connect V3 and V5. That is inside the graph. Okay, so let's connect it, and still one connection is remaining. That is here V1 and V4. And if we connect V1 and V4 to the inside, it will be crossed with the inside edge. And if we connect with the outside, it will be crossed also with the outside edge. Okay, so in any way, it's not possible to make this graph without cross over the edge. Okay, so what does it mean? Embedding is not possible in the K5. So what is the conclusion? The K5 is a non-planar graph. Okay, and after K5, K6, K7, K8, K9, all will be the non-planar. K5 is a subset of K6. Okay, K5 is a subset of K7. If subset is a not planar, so universal set also will be the non-planar. Okay, K6, K7, K8, you cannot make this graph without crossover. Okay, so that is minimum possibility in the K5, which include the 5 vertex only, 10 edges, which is a non-planar graph. Okay. So it cannot be embedded on the plane, and therefore the complete graph with 5 vertex is a non-planar graph. Okay. And then after you also discuss this second graph concept, that okay, why it is also non-planar. Clear? So here you can see this both the graph here. Okay. That is actual shape of the K33. Okay, the first figure A. That is a graph of K33. Okay, and I just modified this graph such a way that we can use this B graph in place of the A. Clear? Why it is that? Because they are isomorphic. Clear? This both graph are isomorphic. They are essentially same that, so we can use the second graph in place of the first one. Okay, to verify why it is non-planar. Okay, what is the reason for that? You just compare this both graph. In the graph A, it has a more crossover comparison to the B. Okay, you just check that there are some more crossover. Okay, is given. Okay. It mentioned in this graph A comparison to the graph B. There are only 3 crossover as the inside edge. So we just focus only 3 edges to remove such crossover. Okay. Second graph में 3 edge cross हो रही है, यहाँ पे ज़्यादा है, ठीक है? So to consider the second graph in place of the first one to verify, to check is it a non-planar or not, is it planar or not. Okay. So consider all the 6 plus as it is that clear, and here proof is not given here. But you can easily prove it by using the proof of last theorem. Okay, by using the similar argument, the proof of last theorem. Okay, consider 6 vertex as a V1 to V6 clear, plot on this plane, and then after connect it, make one circuit from V1 to V6, clear, and at that stage you have two region, one is inside, second is outside, clear. So to connect remaining edges we can use inside as well as outside, okay. And now from three inside edges pick up any one edges that and connect it from inside as well as outside, okay, inside or outside, okay. And then after connect two remaining edges, and at last you get a conclusion. It is not possible to make the graph without crossover the edge. Okay, that is also important theorem. Okay, prove that K33 is a non-planar graph. Prove that K33 is a non-planar graph. So you do not mention this 2 to 4 line. Here you have to apply the similar visualized geometric argument that we used in the last theorem. Okay, K5 is a non-planar. उसको आपको explain करा, उस तरह से आपको explain करना. Is it clear? Okay, so that one of the question is given in the assignment. Clear? So that for practice. Clear? Why K33 is a non-planar. Okay, so that we discussed in the last lecture. Then after the property, that we also discussed that. Okay. That is a 5 vertex with 10 edges. That is a 6 vertex with 9 edges. Clear? So first three are the easy to verify that you have non-planar simple graph, and if you remove one edges, one vertex, then it becomes the planar form. Okay. Now last is important that the first graph of Kurotowski's is a non-planar graph with minimum number of vertex. Compare the vertex to the both graph. So first graph has a 5 vertex, second has a 6. Okay. So it is one of the graph which include the minimum number of vertex. Okay. And second is a second Kurotowski's graph is one of the non-planar graph which include a minimum number of edge. Okay. The first graph has a 10 edges and second graph has a 9 edges only. Okay. So that is for edge. This graph has a minimum possibility, and for vertex, the first graph has a minimum possibility. Okay. That is minimum vertex and it has a minimum edges, which is a non-planar graph. Clear? So that will be asked for when we ask for a 1 mark short question, 1 mark MCQ. Which of the following graph has a minimum number of vertex is a non-planar? Okay. Otherwise, how many minimum number of vertex can be included as a non-planar form? Okay. How many minimum number of edges can be considered as a non-planar form? Okay. So these are the questions answered for that. And have we finished the exercise also? Exercise is pending. Okay. So is there any confusion to verify planar, non-planar or not? Any confusion? So here some exercise is given that, okay? And you have to identify which is a planar, which is a non-planar and so on, okay? Step to verify the planar. If it is directly mentioned without crossover the edge, then you can directly write the answer, it is a planar. Okay, there is no any need modification. If there is some crossover is given to the graph, first apply the embedding procedure, and if embedding is possible, then you can say as planar. If embedding is not possible, then it is non-planar. Okay, that is a procedure to verify planar or not. Okay, so first graph that is clearly a planar. Clear? There is no any cross between any two edges, So it is the answer is a planar. Okay, it is a planar graph. Second, that is also planar. Clear? Number of vertex and number of edges are that. That is also planar graph. Third one, that is a graph of they are isomorphic or not. Let's mention the notation. Third and fourth. There is a third number and it is a fourth number. Is there isomorphic? Third graph and fourth graph. Is there isomorphic or not? Helchan, I have to check the isomorphic. Is the both graph are isomorphic third and fourth? You just compare third and fourth. Okay, no one has replied at any answer. Okay, is there isomorphic? Am I audible? Am I audible or not? Yes, hello, am I audible? Okay. So what is my questions? Is the third and fourth are isomorphic graph or not? What is the definition of isomorphic graph? Okay. So they are isomorphic. Okay. You can easily find image of each vertex of the third graph to the fourth graph. Okay. So you can see this both the graph. This is a planar. Okay. There is no any intersections with any of the edges, but it has some intersections between two edges. Clear? So now just embed this graph. Okay. And you can also consider this graph in place of this one. आप इसको recreate भी कर सकते हो. You can modify the place of the vertex also, and you can consider this graph. Otherwise, just delete one of the edges from the inside and recreate it from the outside. Okay, just remove one of the edges from the inside, and then after recreate this graph from the outside. Okay, let's delete these edges and just recreate it from the outside the graph. Okay, so now this graph look like a planar. Okay, so answer will be planar graph. Yes, all the four answer, all the four graph is a plan. Now next are that the graph is not mentioned. Okay, graph is not mentioned that, but one of the notation of the graph is that you check the following graph, check the K23, K35, okay, K45 is a planar or not. First you have to know how to draw the K24, how to draw the K45. Okay, and then after apply the embedding procedure, is it possible or not? Okay, how to draw the Peterson graph. So just try it and reply your answer. K4 we already checked. Okay. K4 we already checked. So there is no any need to verify the K4 also. Okay. Just try it for K23, K43 and Peterson graph. And reply your answer K23 is a planar, K43 is a planar or not. And you already know how to draw the K23 graph. Okay. How to draw the K43 graph. Practice it. Okay, quiz of unit 5 is pending. Okay, we already finished unit number 5. So we'll arrange the quiz in the next week. Either or tomorrow. Tomorrow is also one lecture we have. So when we'll arrange? Tomorrow, either next week. You have the two options. Tomorrow is the first lecture from 9 to 10. Okay. And from next week, we can arrange on one of the Friday's lecture. Okay. Sorry, one of the Thursday's lecture. This day. Two lecture we have on every Thursday. So when we'll arrange the quiz of unit 5? Okay, so yeah. We'll conduct on next week. Okay? On Thursday. One of the lecture. Okay? Two lecture on every Thursday. So કોઈ એક lecture માં આપણે રાખશું. Okay? Is there any confusion? We'll arrange one quiz of unit number 5 on next week, Thursday. Is it clear? No any reply. Is it okay? Is there any problem? Okay. Okay, next week सेम डे आज 2 लेक्चर है उसमें से कोई एक लेक्चर में आप रखेंगे ठीक है यूनिट 5 कंप्लीट यूनिट फुल सिलेबस MCQ type questions will be there okay as per the you already conduct one test okay so you are aware about how which type of questions will be there okay so what is the answer of K23 is a planar or not K23 graph okay K23 is a planar very good okay you can see this graph here that is a actual shape of K23 vertex in one side, two vertex in other side. Okay. And then after connect every vertex of one side should be connect every vertex of other side. Okay. That is the shape. And as we know one result, which result? We know that K33 is a non-planar. Okay. That is our boundary. K33 is a non-planar. How many edges are there? 9 edges. And how many vertex? 6 vertex. Clear? So less than 6 vertex and less than 9 edges जो भी ग्राफ बनेगा ठीक है that always will be planar graph ठीक है that always will be planar graph less than 6 vertex and less than 9 edges जो भी ग्राफ होगा complete bipartite में that always will be planar form okay so round it is a 2 vertex and 3 edges so it is less than 6 and less than 9 clear data so we can easily embed it clear आप इसको easily embed कर सकते हो as a planar form ठीक है just find the which type of connections we can consider to remove this crossover clear so still two connection is remaining from this vertex to this one and you can consider the below region okay of this graph to connect this one. Now you can see that these are the isomorphic graph okay both are isomorphic you can use this picture this graph in place of this one means both are same दोनों same है because both have same vertex same edges and it is also the one-to-one correspond with all the vertex okay with all the edges so that is now planar form okay K23 is a plan now check for K43 there is a 7 vertex and how many edges 7 vertex and how many edges 12 edges okay vertices are 7 and edges are 12 okay 7 vertex and 12 edges so as we know that K33 is a non-planar in bipartite form okay which include 6 vertex and 9 edges तो इसमें तो उससे ज्यादा है ठीक है it has a 7 vertex and 12 edges तो अगर K33 में possible नहीं है it is not possible to make the planar form in K43 का ठीक है so what is result you can mention it here okay here K33 okay K33 is a subset of K43 okay क्योंकि K33 किस में से बनेगा K43 में से आप बना सकते हो ना by removing some edges and some vertex clear so it is subset of K43 and we know that K33 is a non-planar तो उसका जो universal set होगा ठीक है that is ये subset है and that is it universal set ये main set इसमें से आपने उसको कलेक्ट किया तो सबसेट अगर नॉन प्लानर है तो उसका यूनिवर्सल सेट भी क्या होगा तो डेफिनेटली नॉन प्लानर ग्राफ ठीक है तो K43 is also a non planar graph okay and what about for Peterson graph that is also non planar okay you can see that that is a graph of Peterson clear and there is also psi vertex to the inside clear and if you redraw this graph okay you just try it and at last you get a conclusion that it is not possible to draw this graph without crossover okay without crossover clear just try it you just stretch this inside pi vertex to the outside clear ये जो 5 vertex यहाँ पे है इसको आप outside यहाँ पे put कर दो ठीक है and then after connect it as per the given connection ठीक है this 5 vertex is it is pentagon as it is here and star के जो 5 vertex इसको आप यहाँ पे stretch करो सभी को ठीक है and then after this will be connected here okay and now rest of the 5 connection is remaining and then after try it it is not possible to draw without crossover Okay, just practice it. Your answer is non-planar graph. Now try this one. Here it is embedding procedure. You have to apply that and check it will be planar or not. All of you tried. It's very easy. Okay. Just redraw this graph such a way that how we can remove this crossover, and all the adjacency relations should be same in the modified graph also. Okay, it will be planar graph. Yeah, all of you check it. No any reply, any answer. Harshit, Isan, Jaivik, Neville, Unnati. Okay, is it planar graph? Clear why it is planar graph? Because we have one result in properties of the Kurosawa's graph. Which property? अगर K5 में से आप एक एज रिमूव करते हो, ठीक है? If we connect the B and C, now this graph is look like the K5. Okay, B और C को आप connect कर दो. वहाँ पे अभी एज नहीं है. But if we connect it, so that graph is a K5. And as we know that one result in K5, if we remove one edge from the K5, okay, Kurosawa's first graph, then the graph will convert to the planar form. ठीक है, K5 में से आप कोई भी एज अगर डिलीट कर देते हो तो दैट ग्राफ विल कन्वर्ट टू द प्लानर फॉर्म. ठीक है, क्योंकि एक ही एज लास्ट में रिमेनिंग थी. इफ यू कनेक्ट इट द ग्राफ कन्वर्ट टू द नॉन प्लान. ठीक है, so if you remove one of the edge from this graph, ठीक है, K5 में से, right now this picture is look like the K5 graph if we connect the B and C. ठीक, so I consider this graph as a planar form. Okay, see this graph here, you will get a different graph in place of that. Okay, there are many possibilities to drawing this graph without crossover. Okay, just I stretch this vertex to the inside as well as outside. Okay, modified the place of the vertex also. Clear? And adjacency relation should be same. Okay, adjacency relation should be same in both the graph. Here I rotate this place. Here right now the D is given here. I rotate this place at that upper vertex. Okay, in this second graph. But here you can see that adjacency relation should be same. There is no any edge between B and C in this graph. So it is no any edge between B and C to this graph also. Okay, there is edge between A and E to this graph here, A and E. So there should be also same there. Okay, there is edge between C and D to this graph. So there is also same. Okay, so you can consider this answer as a planar. Okay, and next this two graph you already checked. Clear? That is a K4 graph and that is a K33 graph. Okay, is it visible this line? Okay, let's draw it. There is a black shaded line, so okay, this type of graph. That is a K4 graph. Clear? K4 का ही graph है. And now this you can see is it easily convert to the plan. Okay, and second graph is the K33 that you already checked. Clear? It is plan. Now try it for this one. Yes, Rajvi will say the answer. Rajvi, can you hear me? Is the graph planar or not? Rajvi, can you hear me, Rajvi? And after, uh, Nikhil, Rajvi and Nikhil. Can you hear me,
Yes,
Raj?
sir.
Okay. Have you check it? Is it planar or not?
Sir, it's not planar.
Okay, just verify it again. Just redraw this graph again, such a way that how we can remove this crossover.
Okay, sir.
If you are just join only for attendance, left the meeting right now. તમે ખાલી અટેન્ડન્સ માટે જો લેક્ચર જોઈન કર્યો હોય તો અત્યારે જ રિમૂવ થઈ જાય. તમારી અટેન્ડન્સ ફિલઅપ કરવા માટે લેક્ચર નથી લેતા અમે. Is it okay? ચાલો. Is it planar graph? Clear? કઈ રીતે ડ્રો થશે? Consider the boundary as it is. ठीक है? Consider the boundary as it. All the 6 edges will be as it is here. So just verify your answer with that. Okay? Maybe you got a different answer. Clear? And now that is as it is here. Clear? Still it has no any crossover between any two edges. Okay? And still two connection is remaining to connect. दो edge अभी बाकी है. ठीक है? So if we use the inside way, that we get similar form. ठीक है? So what we'll now do? We'll connect it by the outside way. Clear? ये जो यहाँ पे B और D के बीच में जो edge थी, that I remove it, okay? And I reconnect it from the outside the region. Clear? And same for this one, A and D. Clear? Just remove it from the inside the graph, and then after connect it from the outside. Clear? Now you can see this both the graph, both are same. Clear? Both are isomorphic, means essentially same. Clear? Same number of vertex, same number of edges, but first situation is crossover with crossover, and second situation is without crossover. Clear? So that is a planar graph. Clear? You can consider this answer. Now try this one. Okay, what is the answer? Is it planar? Yes, all of you check it. What is the answer? Okay. So let's verify it is planar or not. Okay, most of you reply that it is not planar, but answer is it is a planar graph. Okay. So how we can recreate the situation into the planar form? Okay. Without crossover. So let's keep all the boundary as it is. Okay. Let's keep all the boundary as it is here with the 5 vertex. And there is one inside vertex is there. Let's put as it is there. And then after connect all this as it is. Okay. Still there is no any problem. Clear? But still two connection is remaining. Okay, two edges remaining, and now up to this stage it is look like a planar form. Okay, so what we'll do now? If you use the same edge inside, अगर मैं एक inside के connect करता हूँ, तो it will be cross with this inside edge. So it is a non-planar. But if I reconnect it from the outside the region, clear? Outside the region, clear? Still is up to the planar form. Okay, and now still one connection is remaining, that is in between A to C. So if we reconnect it, okay, if we consider the as it is formed, it will be crossed with this edge. But we just remove it and we can easily connect from now inside. Okay, we can easily connect it from the inside. Okay, which two edge we have modified? Clear? This two edge, which is this two edge we have recreated. Okay, and then after this. Okay, is it clear? You can see this, all the vertex as it is, all the edge as it is. We have not deleted any of the edges. Clear? We just remove it and we can recreate it. Okay, as per our requirement. Clear? It has same adjacency relation as per the given graph. Okay, there is no any modification. All the vertex have same degree. Clear? As per the given graph. Clear? Both are isomorphic, so it is a planar graph. Okay. So that is the concept of planar, non-planar verification. Clear? Okay, which situation is called planar, which graph is not planar. Okay? And we had discussed some application of planar and non-planar graph. Clear? Now it extended theory. Clear? To region concept, and then after we have one formula that is called Euler formula. To apply this formula to verify graph is a planar or not. Means for every planar graph, this formula will work. Okay? So let's start the next topic that is called a region. Okay. So how we can define the region of any graph? So it is used only for a planar graph. Okay. We can check the region only for planar graph. So first graph should be the planar. Means every planar graph divide the plane into the connected areas. Divide the plane into the connected area. So what is meaning of connected area? Means a closed walk. Okay, you have to find such closed walk from the graph, and you can see that first graph should be the planar. Okay, and this planar graph divide into the plane in such connected area. That is the first connected area. Okay, that is second connected area. That is the third connected area. That is the fourth connected area, and so on. Clear? So to identify such connected area, and that connected area is our region of the planar graph. Okay. So you can put any name for this region. Clear? You can start with any number, start with any region, and you can mention its sequence. Okay? You can give to the number. So that region is the first one. Clear? That is the first region, first connected area. Let us say. Clear? That is the second connected area, second region. That is the third connected. That is the third one here. Three region, and that is the fourth connected area. Okay? So four region you can map to the inside. Okay, inside of the graph, and one common region will map as the outside the boundary. Okay, that will be the open region, but that is a common for all the side. ठीक है, graph की जितने भी side है, that will be common for all the side. Okay, so that is a 5 region. One is the outside of the graph. Okay, and the fifth number region, that is one of the open space. Okay, open space, and that is a common for all the side of the graph. Okay, there is a boundary here, and now in this boundary there are four connected areas. So just mention 1, 2, 3, 4, and you can use any number. Okay, to the any region. You can say this 3 number as a 1, this 4 number as a 2. कोई भी आप number define कर सकते हो. ठीक है? So 4 are the inside, and 1 you have to mention for common. Okay, for outside the boundary, that is region 5. Okay, so here the region lying inside the graph, that is 1, 2, 3, 4. Are called the interior face. Okay, the region is also called the face. Second name for the region. How many faces the graph we have? Okay, how many region the graph have? Okay, so region is also called the faces. There are 4 interior faces. 1, 2, 3, 4. Okay, and one region that is exterior faces. Okay, that is region number 5. Okay, so region lying inside the graph is 1, 2, 3, 4 are interior faces, and region lying outside the graph on the plane is called the interior faces. Okay, that means the part. Clear? And here it is not applicable for a non-planar graph. Clear? We cannot use the region concept for non-planar graph. Okay, this graph is a non-planar, as we know that. So here we cannot assign the region as a 1, 2, 3, 4, 5, 6, and 7. That is not a true. Clear? First, you have to just check the connected area. That is not connected area. Clear? There is no any vertex at the center. If you put one vertex at a center here, okay, if it's 7 vertex now, so now this graph is a planar, and it is a correct 7 region is it. Okay, but there is no any vertex at that place. Clear? So here we cannot assign the region as a 1 to 7 to this graph. Clear? Means non-planar graph. For a non-planar graph, we cannot assign the region. We cannot consider the region. Clear? For example, if we have this graph, that is a K4. Okay, and as we know that K4 is a planar graph, but the situations look like a non-planar form. There is a crossover between them. First, remove this crossover and then assign the region. Okay, here we cannot put 1, 2, 3, 4, and 5. That is not correct. First, remove this crossover, and if it is possible, then assign the region. So here it is possible to remove this crossover in the K4. Okay, that is a K4 graph. Okay, and now you can assign the region as a connected area. How many connected area to the inside? There are 3 connected area. Clear? And that is a 4. 4 is the outside, 3 are the inside. Clear? 4 is the one of the common region, that is for outside region, and there are 3 blocks are given as the inside. Clear? So your graph should be first planar, and clear, if it is a non-planar case, then first you have to modify it as a planar form, and then after give to the region. Clear? So as we discussed in this previous exercise, clear? These are the planar form. Clear? It is a graph here. So questions will be asked such a way that, okay, find the region of the given following graph. Okay, find the region of the given following graph. So first convert this graph to the plan. ठीक है, पहले उसको प्लानर में आपको कन्वर्ट करना है, and then find the region. How many region the graph is lying? Clear? So here, that is one number, that is a 2, 3, 4, 5, and that is a 6. Clear? 6 are the inside, and 1 for the common, that is for outside. ठीक है, you can put this 7 to the any side. आप 7 को कहीं भी put कर सकते हो. You can put here, either you can put this side, you can put this side, and so on. Clear? That is a common for all the side here, so you can put anywhere. Clear? आप कहीं पे भी उसको place कर सकते हो. Clear? And same for this one. First convert to the planar form and then assign the region. Okay? So it is 1, 2, 3, 4, 5, 6, and it has also 7 region. Okay? 1 is for common. Clear? So this way we can check the region for planar graph. Clear? And then after we have one result that, okay, to apply this result, જે લોકો ખાલી અટેન્ડન્સ માટે હમણાં જોઈન થયા ને લેફ્ટ થઈ જાય, મને ખ્યાલ છે કોણ હમણાં જોઈન થયું છે. લેક્ચર ઓલરેડી પૂરો થવા આવ્યો છે. નાઉ લેફ્ટ ધ ગ્રુપ. આવી રીતે ક્યારેય જોઈન નહીં થવાનું લેક્ચરમાં. શરમ નથી આવતી તમને? છેલ્લી 5 મિનિટમાં જોઈન થાવ છો. એટલું ઇમ્પોર્ટન્સ છે તમારી અટેન્ડન્સ નું. Okay. So here one result is that is called Euler formula. In which case you can use the Euler formula. ठीक है? अगर कोई भी ग्राफ प्लानर है, ठीक है, if any of the given graph is a planar, then this formula always will work. ठीक है? What is the formula that? Okay, for a connected planar graph should be the connected. Okay, for disconnected graph, this formula is not applicable. For connected planar graph with n vertices and e edges, with f with number of face, ठीक है, number of region, तीनों डेटा आपको पहले फाइंड करना है, ठीक है, चेक करना है, and then after check this formula, n minus e plus f answer, always you will get a 2. Okay, n number of vertex, e number of edge, and f number of face. So n minus e plus f answer, always you will get 2. Okay, this formula always work for connected planar graph. Okay, so let's verify this formula and then we'll prove it. This graph we have the planar form. Okay, this all the graph. Let's verify this formula for this one. Okay, how you can check it. Okay, so here n is equal to 7 vertex. Okay, there are 7 vertex in this graph. E is equal to how many edges? 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 edges. Clear? E is equal to 11. And faces we already checked, that is equal to 5. Clear? Yeah, there is 8 vertex. Clear? 8 vertex. Now n minus e plus f, that is equal to 8 minus 11 plus 5. So 8 plus 5, that is 13. 13 minus 11 is equal to 2. Okay? So that formula will always work for every planar graph. ठीक है, कोई भी planar graph आपके पास है, that formula will always work. Let us check for the K4. Okay? So vertex is equal to 4. 4 vertex. How many edges? 6 edges. ठीक है? Plus how many faces? 4 faces. So 4 plus 4 minus 6. 8 minus 6 and 8 minus 6 is equal to 2. Clear? If the graph is planar, then it always will work. Clear? And for non-planar graph, we cannot prove this formula. Okay? So let us consider this graph here. And let's take this 7 face. Clear? अगर आपने assign किया उसको 7 face. ठीक है? Vertex are 6, 9 edges. So 6 minus 9 plus 7. That is not equal to 2. Clear? 6 minus 9 plus 7. That is not equal to 2. Clear? So here we have this result. Clear? And we'll prove it. That is also one important theorem. Okay, important result. And it is always asked in a 6 to 8 mark theory in the exam. Okay? State and prove the Euler formula. State and prove the Euler formula. You would also write the statement of that. Okay, for connected planar graph with n vertex, e edges, and f number of faces, then n minus e plus f always equal to 2. Clear? And we'll prove it by using the induction rule. Okay, induction formula. We first check this formula by initial value of the e. Then after we suppose one result, and based on this result, we prove the conclusion. Okay, so that we'll discuss in the next lecture how we can prove this result. Okay, so let's keep up to this.